This is Saxon, excuse me, Saxon Advanced Math Lesson 75, and this is dealing with combinations. Now, I'm going to review just a quick minute here on lesson 41B, which was permutations. A combination is really similar to a permutation, with the only difference being I don't care about the order of the units that I'm taking. Let's see if we can give you a good definition here. A combination is a selection of items in which the order is not considered. So the order of them doesn't matter. It only matters how many I'm taking at a time. For instance, 10 things taken 4 at a time. And the combination, we don't care which one is picked first, second, third, or fourth. We only care that they are in that group. It'd be like saying if I had a group of people and I only could fit 4 or more people in my car, and I said, well, there's 10 of them there, 4 of you are going to have to get into here. That's just what we're talking about. It really doesn't matter who's first in the car. They're still in the car. Who's second in the car. Now, I guess if you care about who sits in the front seat, then you're getting into that permutation thing. But a combination is similar to that, except we don't care which seat they're sitting in, which order they're in. So for this to work, it would be 10, 9, 8, 7, and then we're going to have to divide out of this, right? This would be the permutation. We're going to divide the permutation by the fact that we don't care about the order of the first 4. And how do we come up with the order of the first 4? Well, it's 4, 3, 2, 1, because it's just a factorial to find that. So our formula for NCR looks like this. N minus 1, n minus 2, all the way down to n minus 1 plus 1 over r factorial. Or if you wanted to get into the better method of writing that, which is n factorial over n minus r factorial, r factorial. Now, what do two of these numbers stand for? This is the number I'm taking. This is the rate at which I'm taking them. And I only have 2 variables in there. And it's abbreviated NCR instead of NPR. So looking at this, lesson 41B had this formula here. Notice that we're taking this formula, this NPR formula, n factorial over n minus r factorial, and we're just substituting into it, we're adding to it this r factorial. What we're saying is, I want the permutation divided by how many I'm taking at a time, the rate at which I'm taking, so that the order is eliminated. A permutation is a much bigger number than the combination would be, because in a permutation I care about the order at which I am taking them, where in a combination I don't. Let's look at an example here. 5 students, this is 75.1, 5 students from a group of 12. So I'm going to do this with NPR and then also do it with NCR. So NPR would be if I cared about the order. It's 5 students in order, right? This might be like I said, somebody cares about the front seat, and then the next one gets to pick the next seat, and so on. So 5 students arranged in order. I would do an NPR, so it's 12 factorial over 12 minus 5 factorial. That's n over n minus r factorial. That's going to give you 95,040. Well, if you could do the same thing if you looked at it and realized 12 minus 5 is 7, the 7 factorial, so 12, 11 times 10 times 9 times 8 is 95,040. That's a lot of different ways. However, I don't care which order they're in. It's just 5 students from a group of 12, any 5 students, and they can be in any order that they are in. It doesn't matter if they're picked first or fifth. Okay, those seats, there is no seats in order. Then I'm going to use an NCR, a combination, and that's going to give me 12 factorial over 12 minus 5. Notice that so far we're exactly the same. Then we're substituting in our r factorial again, so we're putting that rate that I'm taking them back in again to it and dividing that out. I put this up here. This is how you're going to do this on a calculator. If I wanted to do 12 or NCR with a calculator, I'm going to label that n is 12 and r is 5. And calculator, if you're using the TI series, they're a little bit backwards in the way they go in, because if you just put in NCR 12.5, how would I tell the difference between that and 125? Right? There would be no way to differentiate. So the way that the programmers design that TI series calculator for 84 or 83 or 84 plus or 84 silver plus CE or whatever it is, the way they program that is that you're going to put in the first number, your n in first, go to the math and hit NCR, and then add the second number. We do the same thing with the NPR. It's actually right below NPR in that list. or might be right above it actually, of the list underneath PRB. So this is the menu method of doing this. With this problem, I'm going to put in 12 to begin with. I'm going to hit the math key, okay, and I forgot my little, there you go, our math key. I'm going to arrow on over 1, 2, 3, 4 times, I believe, PRB, and then I'm going to go down to the third one. It is the third. The second one's in PR. The third one, which is in CR, I'm going to leave it selected on that, hit enter, put in my 5, and that'll bring me back to the main screen where it'll say it'll say 12 in CR, and then 5, and I added that 5, and then I hit enter, and it's going to give me 792. If I want to do it manually without the calculator, I can do the same idea. This becomes 12 times 11 times 10 all the way down, except that I already recognize that I can get rid of the 5 factorial, right? And that goes away, and that gives me inside of here 12 minus, well, either the larger one, 12 minus 5, which is 7 factorial. Cancel that out, leaves me with a 5 factorial. So that's here. If I did this by hand, I still end up with 792, although the calculator is definitely quicker, especially on the bigger number sets. You can save a lot of time. So this is combinations, very similar permutations. If you need to go back and watch lesson 41B, the video is available. Please feel free to refresh yourself if you need to on MPR, but once you know what MPR is and you realize that's when you care about the order, in CR you don't care about the order, it's pretty easy to differentiate and to read a problem. For the first couple of homework problems you'll see on this, you will notice that they tell you this is a combination. This is a group that I don't care about the arrangement. A little bit later on, they're going to leave that little piece of information out of the word problem, and you'll be responsible to read the word problem and to determine, is this an NCR or an NPR problem? And the easy way to answer that is, do I care about the order at which I'm taking this group out? If I care about the order, it's an NPR. If I don't, it's NCR.